corrections due by the end of the day for your graphing calculator quiz. But as far as us in class, our top priority is notes so that you can finish homework tonight for tomorrow, and then with extra time, worksheet. Any quick questions before we just go for it? So,
remember how I think a different way I learned this?
This as
how to
in
complete the square.
Oh,
For the vertex.
yes.
I found it. Changed that instead.
Yes, but only if you show it to me.
Okay.
Not right this second, but
Yeah.
maybe if we start working on the worksheet. But yeah, I'd love to see it, and then yes. Did we write all this down on Friday?
No,
Oh, okay. But you have it now, yeah? Okay. I want you guys up here, useful form. I'll say useful. Let's see. How could we describe this a little bit? What is the standard form useful for? And quick reminder, this was called vertex form last year, right? Okay. It's useful for seeing transformations. It's useful for graphing. And it's useful for the vertex. What is factored form? If you want to write it out. What is factored form useful for?
For random point.
X-intercepts. Yeah, that's what I was thinking. Factored form is really useful for x-intercepts, aka for zeros, right? So different forms are useful for different things. Vertex form is useful for graphing and for finding the vertex, the maximum or the minimum, which on your worksheet is a big deal. Factored form is useful for finding the zeros, but can every quadratic be written in factored form?
No. Not all that high.
Hence why we talked about the quadratic formula for quite a bit on Friday. Okay, now zooming in on the second page, because this is where we finish the material for section 2.1, which we're trying to catch up on today. If you needed to fill in any information, now's the time. Except, do I really need you guys writing vertex is lowest point? How can we summarize that? Yeah, can't we just say like, oh hey, when you have concave up, the vertex is the minimum, right? And then vertex is the highest point. Okay, good. It's not bad. What's a better way? Hey, when I have a concave down parabola, then my vertex is going to be the maximum, right? Okay, highest point, maximum, lowest point. The reason why they put lowest and highest is, can you guys look at the back of your worksheet real quick? The very last 4 problems where there are lots of words. You just read those words really quickly and find for me the keywords that tie together with what we just wrote down, maximum and minimum. What words do you see? Okay, so maybe it actually says max, maybe it actually says min, but what are the other words?
Largest.
Largest. Wait, what's largest? Another way of saying it. Maximum
Tallest.
area or maximum volume. I don't think tallest is on there. Is there another word? Highest? Height? Highest? Maximum height? Anyway, so even though, yes, it's a max on a graph and a min on a graph, knowing lowest and highest might prepare you for some work. Bless you. Bless you. Leading coefficient is positive if A is greater than 0. I have a concave up, which opens upward is okay. But I like saying that it's concave up like a cup. And then leading coefficient is negative if A is less than 0. Then I have concave down like a frown. Opens downward. That's another way of saying concave down. I know. Although concave down has max. Oh, what's that?
Did you know that women takes more muscles to frown than to slouch?
Yeah, crazy.
So,
But I think it depends on your face structure to some extent. Because you know some people just kind of naturally look like they're frowning. You guys probably don't know her. She's an old actress, Sally Fields. She always kind of had like very...
She's the one that had like purple eyes or something.
Oh, she should have glasses. I don't remember anything recent that she's been in. I don't think she was in first. She has kind of sad eyes in her face. Like her face, like when she was just normal. So some people have a natural frown, but yes, Alex, that is generally true. Vertex, we already know that he's at HK, right guys? each k of the vertex form the standard form. If A is less than 0, oh, I was going to put concave down here. Oh, well, that's okay. Oh, no. We already talked about that. No. Sorry. A is less than 0, concave down, my vertex is a max. I will have a maximum. If A is greater than 0, concave up, we'll have a min. This might seem so basic and so simple, but when you get to calculus, it gets so tricky. The max and min idea. So it's really important to know concave down has a max, concave up has a min. Axis of symmetry. What does that do?
Where it meets the vertex.
Yeah, the vertex can be the x value of the x value of the vertex. The vertex is always on it.
H.
Yeah. And what did we already know about H? I'm gonna go get my little like starburst thing. Sure.
What?
It's a little sun. Isn't there a formula for H? Okay.
Oh,
So the axis of symmetry always goes through the vertex. As it goes through the vertex, well, H equals negative B over 2A will always be the location of the axis of symmetry. So hold on, look at your worksheet real fast. Aren't there some blanks where it says axis of symmetry? But what's above the axis of symmetry blank?
hold on.
The vertex. Well, won't you always just be stealing the H of the vertex for the axis of symmetry? But careful. Isn't it an x equals equation because it's a vertical line, right? When would the axis of symmetry not be vertical?
Oh.
If it's
an x equals y.
If it's an x equals y squared, if it's a horizontal parabola, and if your axis of symmetry is the k value instead. Oh. Anyway, that's fun. What else do we have? So, what have you seen this in homework? Ready, set, pause on the worksheet. Let's make sure we're good for homework. Top priority, right? Identify the vertex and the axis of the parabola. Oh, that's it? Oh, and sketch. In some ways, I'm a lazy person, meaning I take a second to think about the problem and I try to go about it the easiest, most efficient way. Maybe I'm lazy and yet I still want to do things well.
Big brain.
It's not impossible to do both. Efficient is usually trying to do something the quickest way. And yet the right way. Okay. The quickest right way is not in your calculator. Is not making a table with x equals -2, -1, 0, 1, 2 from like algebra 1. The quickest right way might be, well, factoring might get me towards the vertex, but would factoring necessarily get me the vertex? Let's think about it. Okay, factoring. I would do 2 times 7 is 14 and then 8. I don't think I like factoring anyway. But I'm not sure factoring would have gotten me where I wanted to go anyway, either.
Quadratic formula.
Quadratic formula would find me the zeros. Maybe we should just complete this one. Incomplete square, we've already talked about that. Been there, done that, true. Okay. Complete the square, already been there, done that. So we're trying to get a leading coefficient of 1 by factoring out the 2. We get our special middle term by taking the middle, cutting it in half, and squaring it. 2 squared. So why am I doing a -8?
Because you're multiplying it by 2 on outside.
The 4 is actually an 8 because of this 2 out here.
Well, why is it negative?
Because the name of the game is balance, right?
Oh, yes. Oh.
So if I add on one side, either I add on the other, but then it messes up my form, or I add on one side and subtract somewhere else. Either way, I'm balanced. So I'm adding one place, subtracting somewhere else.
Wait, where'd you get it?
By filling in the 4, it's actually a quantity of 8 that I'm adding. Oh, name of the game is, well, I already have it balanced. Okay, now I just want to simplify it. You guys remember the trick about always knowing what comes after the x in my form?
It's the one without the square.
Yeah. And that's a positive number, so it must be a positive 2. So plus 2. You could always do your little x. You could say, hey, what multiplies to 4 and adds to 4 and positive 2, positive 2. Squared x plus 1. And then minus 1.
Big one.
Couldn't I say my vertex? X minus 8. And then plus, okay, minus 1. So remember your form is. And this might be a good thing to write at the top of your worksheet, a quick reminder of the standard form where you can find the vertex of H, K, and your axis of symmetry. That might be something that might be helpful for that worksheet.
Yeah.
Vertex, check. Graph, axis of symmetry. Check. I just get to steal the H. That's nice. Okay, so I've done half of the problem. Well, 2/3 of the problem. I still need to sketch. So what's the dilemma? How many points do we need for a parabola again?
Like 3.
2 for a line, 3 for a parabola. So I still technically only have 1.
You just had to plug it in.
Oh, I guess we could do that. P.S. Just thinking about the worksheet. Is this vertex a max or a min? Why?
Because it's positive.
Good. Does that make sense? That's going to be a min. Because technically looking up here, since this guy is greater than 0, that means I'm going to have a concave up as a min. That means it is going to cross through the axis. So technically, we could just plug in random points like, well, we know where it is at -2. How about -1? And how about -3? And then we could just go, swoop, there it is. We could also realize that this concave up is going to hit the axis somewhere. So maybe the zeros might be helpful. But if we remember, or if you guys remember, it was not going to be a nice factoring problem anyway. I don't know if you feel like the quadratic formula. I kind of don't, because then we have to do decimals and approximate. So are we okay just doing the old-fashioned lazy?
Yep.
We know where the vertex is. Just go on either side and you have an idea. So -1, what are we going to have? We're going to have a positive 2 minus 8, -6, plus 7. Which means the 0 had to happen somewhere in between there. It's going to swoop up and hit it. -3, wait.
That has to be -1. It's symmetry.
That positive one.
Oh,
But
yeah.
yeah. I can totally, remember, I want to be efficient. But that means I want to do it quickly and right. So if I know that I can go right 1 up to 1, I can go left 1 and up to 1. Well, that's sweet. I guess maybe we only need 2, and then as long as we're on either side of the vertex, we can just copy it on the other side. Which is nice, because I didn't really want to plug in -3 anyway. Are we done now? Sketch. Got him. Vertex. Got him. Axis. Got him. Done. Okay. Well, that wasn't too bad. I think we were kind of ready for that. Oh, I guess we're also ready for it. Okay. Now, with homework. Let's see. I don't think you guys need that one. That one's kind of a basic-y one. Let's get rid of that page. This one's a little bit nastier, but we did some nasty complete the square already, didn't we? We did a nasty fraction one, if I remember right. Let's peek at our worksheet for a second. Help me out. Is this an actual problem on the worksheet? I don't actually know. 3x squared minus 9x plus 12. Okay. But is it similar to what's being asked?
Yeah.
Yes. All right, so if we want to find the vertex, the max or min, the axis of symmetry, the zeros, depending on the question, you might be asked different things like this. And I actually need to add one extra line in here, because it's going to say a max or min. And I think it's going to say something sometimes like of, and then at. Yeah, that's kind of what I was planning on. Does that sound good? Okay. Now, you might not realize it, but almost everything I do in pre-cal is either, well, it's for the purpose of your pre-cal book and your pre-cal homework, but it's also for the purpose of calculus. And this worksheet is one I always refer to calculus kids the year after they have. But sadly, only honors gets to see it because regular we just kind of take a lot of time on factoring. Like, let's review factoring, let me teach you factoring. For you guys though, I'm like, now the worksheet's more important because I assume a lot of you go into calculus. So this is just like straightforward stuff, right? It is a little bit harder because what's the first thing that you would probably do? Should do. Factor out the 3. But hold on. I also use this example for a couple reasons because you're going to want to factor him away from everybody. But what don't I want you to do? Or what do I want you to do with the 12? Keep it separate. Keep them separate. Now in a second, we'll talk about his factoring and whether or not he had nice factors, but for right now, he is not a perfect square. I guarantee it, because if I take half of him, well, first of all, he's not a nice square, and he's not a nice square, so it doesn't look good. So move that 12 off to the side. So you can fill my blanks. I'm filling my blanks with, is anybody getting a 9/4 when you cut the middle in half and square?
I don't appreciate that.
Sorry.
Well, why is this one a plus? Next to the 12.
This one's always a plus, because whenever you square a positive or a negative, you always get a plus.
Well, what about the one next to the 12? Because like on the last one that you did.
I'm about to write a negative.
Oh,
You're right.
okay.
You're right.
Muy bien.
No, you're right. I'm going to do 27/4 out here. If you got stuck, remember we're taking that middle term, we're cutting him in half and then squaring him, right? So 3/2 times 3/2, or 3 squared over 2 squared is 9/4. I had to do my 3 times, or my 3/1 times 9/4 to make sure I put a negative like Jaden wanted.
Why'd you hit the 4? Underneath.
Oh, by squaring the 2. By cutting him in half.
So you did. Oh, okay. I see.
Yeah. Middle term cut in half. Oh, but wait a minute. That was a -3, right? Oh. But does that affect this dude? What's a negative square? Okay, so it doesn't affect him. But it does affect when I get into my vertex form, because my vertex form says factor and keep this guy, right? So it's x minus 3/2 squared. Now, I have a question for you. How did I, or how am I about to, write plus 27/4? How did I do this mental math? Because that's not a mental math thing for most of you. How did I get 27/4? Which is amazing, because you can still keep pondering how I got it. But I love having 27/4 because then I can just go ahead and throw in my vertex without having to do that crazy starburst thing. Oh, I multiplied? Yep, I did. I got a common denominator. Put them over 1, multiplied by 4/4. So I ended up being able to do this by doing 48/4 minus 27. And I was lucky because this is a little like put him on top, and then 4 minus 2 is 2, 8 minus 7 is 1. It was a...
That's a little bit like
Oh, I didn't write 21. Man, I failed.
there. That's it.
I thought 21 and I wrote something else. That's a bummer. Well, I guess I did bad mental. That is bad. See? Once you do it once. There we go.
Wait, where did you get it? 21?
Because she multiplied 4 by
I got a little common denominator. So 12 is really 48/4, and then I subtracted 27/4. And 48 minus 27 is 21. Which some of you, once again, you're like, wasn't there another way? And Sophia might have yet another way for us. But our other way for right now is we could have done H with our formula. H equals negative B all over 2 A, which is 9/6, which is 3/2. We could have gotten that real easy. When does it get hard? Who else did we need? Ugh. And to get him, do you realize that we would have, instead of just arriving at the answer, we would have had to have plugged in from the very beginning and done, oh no, 3/2 squared plus -9 times 3/2. If you didn't like this little baby one, you're not going to like that one. So, my own personal preference is just to do this little baby one instead of that big one to get there. How are we going to answer the max or min? A is positive, therefore I have a concave up, which means this guy is a min. Now, hold on. If I were you, I would write a note to yourself. The of, when I'm saying max or min, I'm saying value. And when I'm saying value, I mean function value. And so the minimum value will be of, or symbolic of, or identifying the y value. Function value is the y value. The at is when it occurred, which is the x value. So the minimum value is 21/4. That's how low the function goes. And where it happens is at 3/2. Where it happens, you can even say x equals 3/2. I wouldn't mind that. But the minimum function value is of. You put the y there, the x there. It's as easy as that. The axis of symmetry, we get to steal the x, so that's easy. X equals 3/2. But how do we find the zeros?
Can I just grab it?
You could try to graph it. Or don't we not mind zeros if the factoring's easy? Is the factoring easy?
Maybe not.
Maybe not. Because if I use 4 and 1 to get 3, isn't that going to be a positive and a negative? That doesn't work so good. So, quadratic formula, but I've done so much work already. Where did I say the quadratic formula came from?
The graphic does.
B in the square. So couldn't we just steal him and then just go 0 equals 3 times x minus 3/2? And I'll even be super nice and not make you guys simplify if it's a nasty one. Nasty one? Is it a nasty one? I would have to subtract the 21/4. I think Emily's saying something. And then I'd have to divide the 3. And then I'd have to square root. Guys, why should I just stop and say none? What's going to happen? It's a negative. That's a... Oh, well. Good thing I didn't work too hard on the quadratic formula. Now, are all of them that nasty on the worksheet? Number 3 is a little gross with some decimals. Decimals? I made some quadratic formulas. But the other ones, there are some nice ones. There are some nice ones, and there are some mean ones. However, do you guys want to peek at those nasty ones at the end again of the worksheet? Yeah. Why is this one the very last question? Why is he a quadratic question? Oh, second to last? Why is he a quadratic? Who sees the quadratic in here?
I don't.
Well, I just see the idea of max. And what's the only kind of max we know how to find right now? By hand? The vertex of a parabola. So I hope it's a parabola. Otherwise, I'd want to use my calculator, and I haven't said yet you're allowed to. Aww. But how do we find the max of an equation that we don't know?
Then graph it.
Graph what? You need an equation, don't you?
The magic
You need
calculator.
an equation, though.
The magic con.
Wait a minute, isn't this how long fencing we have? Couldn't we say something like the perimeter is 500? Which could lead us to y is equal to 250 minus x if we got y by itself. But wait a minute, they don't just tell me that. What else do they tell me? Area. Well, isn't area x times y? Didn't we learn in old word problems sometimes we can plug in short stuff? And can't we rewrite this to be a quadratic?
How about you?
And isn't this quadratic one that's concave down? And doesn't every concave down parabola have a... What? Sketch part with it. This worksheet is not doing so.
Wednesday.
Okay, so you have to finish it all tonight. You can play with it, but don't play with it until you do what?
Other homework.
Homework first. Priorities. Keep your priorities straight. That's an important life lesson for you. But, wrapping calculator corrections, if you guys have any questions, I'm here. During lunch, maybe a student council meeting, we can like hop in. Or period 7, or after school if you need to ask me anything, or if you're all done with it, you can stay put on top. To your folder. You guys are period 4. Don't forget, and the bell's about to ring, and it's off. Can I show you? Relax for 20 seconds. We were productive today.
Yeah. Are you?
Yes, I'm actually staying.
You're actually going to on the bus today?
Yes.
Correct.
Great heart goal.
You don't blow over.
Just mix it. Couple of Papa Pandit video. Papa video. Papa video.
I couldn't find the video. It's like